Okay, so lately we've been dealing with angles, the sine, cosine, and tangent of angles that are bigger than 90 degrees, bigger than 180 degrees. We've also started looking at angles with negative measures. And what we found is when you have angles that are bigger than 90, bigger than 180, or that are negative, you can get sines, cosines, and tangents that are negative. They don't always have to be positive. So we've talked a little bit about how we determine that, because sine and cosine are the y and the x value wherever the angle hits the outside of the unit circle. But this is another trick we can use to remember where the sine, the cosine, and the tangent are positive and negative. And it's I guess it's an acronym. It's ASTC. All students take calculus, or some people say all students take classes, because not all students actually do take calculus. But because this is a pre-calc class, we're going to go all students take calculus to encourage everybody to take calculus in the future. So, anyways, the meaning of this, the A stands for all, and you start in quadrant one. So in quadrant one of the coordinate plane, any angle that falls in that quadrant is going to have a sine, a cosine, and a tangent that is positive. So your sine is positive, your cosine is positive, and your tangent is positive. And as a result, your secant, your cosecant, your cotangent also positive. So quadrant one, any angle that falls in there, any angle that falls in quadrant one would be like the type of angle you could put on a right triangle. And that's going to give you positive values for all your trig functions. When you go to quadrant two, if you think about quadrant two, the x value now in quadrant two is negative. And so the only thing that's going to be positive here is of sine, cosine, and tangent is the sine. So that's why quadrant two, we have an S. S stands for sine. The sine is positive. The cosine and the tangent are both negative. Now, the reason the cosine is negative is because in quadrant two, the x value is negative, and cosine is the x value. The reason the tangent is negative is because tangent is sine over cosine. And so if you have a positive sine and a negative cosine, positive divided by negative is going to give you a negative. So cosine and tangent are both negative. Sine is positive. So S stands for sine because that's the only of the three that is positive. When you get to the third quadrant down here, the only one of the three that is positive is the tangent. So when you're in the third quadrant, the x and the y both are negative. So sine and cosine are both negative. But when you do tangent and you do sine over cosine, what you end up with is a positive over a positive, or I'm sorry, a negative over a negative, which cancels out and gives you a positive for your tangent. So your sine and your cosine are negative, your tangent is positive. So the T stands for tangent because that's the only one of the three that is positive in quadrant three. When you go to quadrant four, you've come back around. Now your sine is still negative because your y value is negative. You're on the bottom half of the graph. But your cosine becomes positive again because you're on the right side of the graph where x is positive. So your sine is negative, your cosine is positive, and because you have one negative and one positive again, we are back to where tangent is negative. So the tangent is a negative divided by positive, so we get negative. So all students take classes. The A stands for all because in the first quadrant, the sine, the cosine, the tangent, all three are positive. The S stands for sine. In the second quadrant, only sine is positive, cosine and tangent are negative. T stands for tangent because tangent is positive in quadrant three, sine and cosine are negative. And C stands for cosine. Cosine is positive in quadrant four, and sine and tangent are negative. The secant, cosecant, and cotangent just follow the ones they go with. So if the sine is positive, and I think I mentioned this when we were talking about quadrant one, that's a bad S, but the cosecant is also positive. If the cosine is positive, the secant is also positive. If tangent is positive, the cotangent is also positive. And that follows all the way around. Cosecant, secant, and cotangent just follow their reciprocal functions. So let's do some examples on this. And one thing I didn't talk about here that we'll see in the examples is not every angle hits in a quadrant. You also have angles that hit on an axis. So you have like the angle pi over 2 or the angle pi. So we're going to talk about those in our examples because those are special cases. So here we have a chart, and we have 5 angles, all measured in radians. And we want to figure out if the sine, cosine, tangent, cosecant, secant, and cotangent are positive, negative, or, and this will come up in a couple special cases, undefined. So let's start looking at this. So the first thing we have to do when we have an angle measurement in radians is figure out what quadrant it is in. Now, there's a couple different ways you can do that. One is you can convert it to degrees. So let's say 4 pi over 5. Let's say I don't really know where that's going to go on my graph, on my unit circle. So I'm going to convert it to degrees. So 4 pi over 5, going to divide that by pi, multiply it by 180. Pi's cancel out. I have 4/5 times 180. And when I take 4/5 times 180, I will end up with 36 times 4, which is 144 degrees. So 4/5 pi is 144 degrees, and I know 144 is in between 90 and 180, so that's going to put me in quadrant 2. And in quadrant 2 of sine, cosine, and tangent, the only one that is positive is sine, because we have the s. So sine is positive, the other 2 are negative. Then to do our reciprocal functions, it's just going to repeat. Cosecant always matches up with sine, so it has to be positive. Secant goes with cosine, it will be negative. Cotangent goes with tangent, it will be negative. So that's one way to do it. If you're not sure where the radian measurement would put the angle, change it to degrees. Another way to think of 4/5 pi, though, is you know it's less than 1 pi, because 4/5 is less than 1. It's a proper fraction, so it's less than 1. You can also see here, if it's 4/5, that's bigger than half. So it's got to be bigger than pi over 2. So that's another way to think of it, that it's bigger than pi over 2, but not big enough to be pi. Here's another way you can think of it. So that the second example is 10 pi over 7. And I'm going to erase some of this extra writing so we can just focus on the second one here. All right, so 10 pi over 7. When I'm thinking through that, I know that's bigger than pi. So I know I'm on the bottom half of the graph because it's not big enough to be 2 pi yet. But I don't know if it's going to be quadrant 3, quadrant 4. That's kind of tough. It's going to be really close. So here's another way to do it is to take your radians. We usually express radians as a fraction with pi in it, but you don't necessarily have to. We can make these into decimals. So I'm going to do that really quick. So pi over 2 as a decimal is approximately 1.57. And that is approximate, but it's pretty close. Pi as a decimal, of course, is approximately 3.14. 3 pi over 2 is approximately 4.71. And then when we get all the way around to 2 pi, that is approximately 6.28. So now if I can take 10 pi over 7, plug that into a calculator, make it a decimal, the decimal for that is approximately 4.48. That tells me, okay, 4.48, it's bigger than 3.14, it's less than 4.71, so I'm going to have to be in quadrant 3. So that's another way you can think through it if you want to. I'm going to be in quadrant 3. And now I can fill this out. Quadrant 3, the tangent is the one that's positive of the first 3. The other 2 are negative. And then we just match up the reciprocals. So cosecant would be negative. Secant would be negative like cosine is. And then your cotangent would be positive. So a couple different ways. If you're not sure where the radians are going to put you, you can change the radians to a decimal and use decimal approximations, or you can change the radians to degrees because you know where 90 degrees and 180 degrees and 270 degrees are on the graph. All right, erasing the extra stuff again. Let's go to the third example. We have a negative a negative measurement here this time. We have negative pi over 5. So there's two ways you can do this. The first way, I'm going to go back to what we talked about on a previous lesson this week. When you have sines and cosines and tangents of negative angles, we had a rule for that. So we had a sine of a negative angle is equal to the opposite of sine of the positive angle. So if you can find the sine of the positive angle, you just make it negative. A cosine of a negative angle actually ended up being exactly the same as the cosine of the corresponding positive angle. And then tangent was like sine. Tangent of a negative angle is opposite of tangent of the positive angle. So you find the tangent of the positive angle and change its sign. So if what we want to do here, if we want to forget about the negative for a second and say, where is just regular old pi over 5? Well, pi over 5, it's a pretty small fraction. It's definitely less than pi over 2. So it's going to be somewhere in here in the first quadrant. And in the first quadrant, my sine, my cosine, and my tangent are all positive. And then I apply my rules. Well, if I'm doing sine of a negative angle, I take the sine of the positive angle and I change the sign. So it was positive, that's going to become negative. Cosine of a negative angle is the same as the cosine of the positive angle, so it stays positive. Tangent, we change the sign again, it goes negative. So that tells me here, I'm going to have a negative sine, a positive cosine, and a negative tangent. So that's one way to look at it. Here's another way to look at it. Remember, negative angles, we start on the x-axis, the positive side of the x-axis, like we always would. But instead of going counterclockwise like we normally would, we go clockwise. So instead of going up this way and around, we go down this way. So a negative pi over 5, and let's make sure we do see that negative there. A negative pi over 5 is going to put us down in quadrant 4, because if we start at the x-axis and go clockwise, we're going to end up down here somewhere. So we're going to be in quadrant 4. Now in quadrant 4, we have the C for cosine. So cosine is the only one of the first three that is positive. The other two are negative. And you can see here, that's exactly what we got when we did it the other way. So cosine is positive, sine and tangent are negative. And then we can fill out the reciprocals by matching them up. So with negative angles, there's two ways to look at it. And it's just going to depend on the angle itself and whatever is easiest for you to visualize. Some angles, it will be really easy. Like pi over 5, if you make that negative, it's pretty easy to see you're not going to go very far. So you're just going to end up in quadrant 4 when you go the opposite direction. But there will be other angles where it could be very hard to tell. So you might need to look at the positive version of the angle, change it to a decimal, change it to degrees, something like that. So it'll depend on the angle which way you want to do that. All right, finally, we've got two special cases. We have pi over 2, and we have plain old pi. And you'll notice pi over 2 and pi are on the axes. They are not going to put you in a quadrant. So let me get my pen back here. So let's look at pi over 2. Pi over 2 is a 90-degree angle. It puts you right here at the top of the graph. And if you think about that point, because remember, your sine and your cosine are based off the coordinates, where the angle hits the unit circle. And if you're up here, you're going to be at the point 0, 1. So that's where you're going to be. And now that I look at this, and I should probably redo the video, but I probably won't. So I'm just going to make a change right here. I said positive, negative, or undefined. There's actually another option, which I should have had up here already. And that is, a number doesn't have to be positive or negative. It can be 0. So I'm going to squeeze that in there. Squeeze in my Oxford comma. So it could also be 0. So if we have a pi over 2 angle, a 90-degree angle, that puts us at the point 0, 1. And remember, our x value is our cosine and our y value is our sine. So here, the sine is positive because it's 1. 1 is a positive number. The cosine is 0. And then if we have to do tangent, tangent, again, is sine over cosine. and my sine of pi over 2 is 1, my cosine is 0. So if I try to do a tangent of pi over 2, I have to divide by 0. So I cannot do that. So my tangent is undefined. I'm just going to write undef for my tangent. Now with our reciprocals, we got to be careful here. So what we're thinking about is what happens if we start to flip this. And so if we flip our sign, if you flip a 1, 1 is just 1 over 1. And if you flip that, it's still 1 over 1. It's still positive. But when you do cosine, our cosine is 0. And if you think of 0 as a fraction, that's 0 over 1. And when you flip that, 0 over 1 becomes 1 over 0. So the reciprocal of a 0 is going to be undefined. And then it works the other way too. If you have an undefined tangent because it's 1 over 0. But if you do cotangent, you're going to flip that 1 over 0. And now the 0 is going to be on top and the 1's going to be on bottom. And that's not undefined anymore. That's an actual number. That is 0. So we can fill that in. So that's the one, kind of the one exception to the rule here. If you're just doing positives and negatives, the sine will always match the cosecant. The cosine will always match the secant, and so forth. But when you start getting zeros and undefined, if you have a 0 cosine, the reciprocal, the secant, will be undefined, and vice versa. If you have an undefined tangent, the cotangent, the reciprocal, will be 0, and vice versa. So let's look at one more example here. We have pi. So pi is on the x-axis. And I'm going to, one more time, erase some of this stuff to make some room. And we'll take a look at where pi puts us. So pi is going to put us out here on this side. And so when we hit the unit circle out here, the point is going to be -1, 0. So our x is -1, our y is 0. So in this case, our cosine of pi is our x value. So cosine of pi would be -1. So the cosine here would be negative. The sine of pi is going to be 0 because the y value is 0. So our sine is 0, our cosine is negative. Now to do tangent, we're doing sine over cosine. So tangent of pi is the sine, which is 0, over the cosine, which is -1. Now we can take 0 over -1, it's just 0. So the tangent will also be 0. And that's one thing you'll notice. If your sine is 0, your tangent will always be 0. If your cosine is 0, your tangent will always be undefined. So let's go to our reciprocals now. We have 2 zeros. Both of those zeros, when we take the reciprocal, are going to be undefined. So our cosecant will be undefined. And our cotangent will also be undefined. Because if we flip those, we're going to get something over 0. And we can't do that. Our secant is going to follow the cosine. If our cosine is negative, the secant is also negative. So we don't have to do anything weird with that. So that's kind of the key thing. We have all students take classes that tells us where the sine, the cosine, the tangent, and by extension, the cosecant, the secant, the cotangent are positive and negative. But we also have these angles that hit the axes, and we can get 0 and undefined. And just remember, if you get a 0 for your sine, your cosine, or tangent, the reciprocal will be undefined. If you get undefined for sine, cosine, and tangent, and you're not going to get an undefined sine or cosine. But if you get an undefined tangent, the reciprocal then would be 0. So there you go. That's all students take calculus, and hope that all makes sense.